Welcome to the Material Science and Advanced Manufacturing podcast. Today, we are going to do a deep dive into the world of laser plastic welding.
Yeah.
It sounds kind of complex, but I promise we'll make it pretty easy to understand,
Right.
even if you are a complete beginner.
Absolutely.
So to start with, what exactly is laser plastic welding?
It's a very precise way of joining plastic parts together using a laser.
Okay.
Think of it like a super tiny, intensely focused beam of heat that melts the plastic at a molecular level and fuses the plastic together.
Okay, so no glue or anything like that?
Exactly, no adhesives.
Huh, interesting.
It's all about the laser energy directly interacting with the plastic and creating a really clean, strong, hermetically sealed joint.
Okay, so how does this actually work in practice?
Well, it starts with clamping the two plastic parts together.
Okay.
And they have to be held in very, very close contact, like no gaps allowed.
No gaps, sorry.
And then the laser beam is precisely targeted at the joint.
So why is the no gap thing so important?
Well, one of the plastics needs to be transparent to the laser's wavelength,
Okay.
and the other plastic needs to absorb that laser energy.
Okay.
So when they're in perfect contact like that, the laser focuses its heat precisely where those two plastics meet,
Okay.
creating a very localized melt zone.
So it's like a tiny little welding torch.
That's a great analogy.
Huh.
And then as the laser moves on, the melted plastic cools and solidifies.
Okay.
And that's what creates the strong, permanent bond between the parts.
That's really cool. And this method is becoming incredibly popular right in manufacturing. Why is that?
Well, for starters, the precision that we talked about leads to super clean joints
Okay.
with minimal flash, which is, that extra material that you often get with traditional welding.
Right.
So it's a huge win compared to other techniques like ultrasonic or vibration welding.
So less waste less time cleaning things up.
Exactly.
Okay.
And the efficiency goes beyond just the welding itself.
Okay.
Laser welding is very fast, which makes it great for high-volume manufacturing. And then there's also no need for extra materials like adhesives,
Okay.
which makes the process a lot simpler and also more environmentally friendly.
So we've got speed, precision, and it's green.
That's right.
It's starting to sound like this has it all.
Well,
Are there different types of lasers used for this?
yes. And this is where things get really interesting.
Okay.
The two most common types are 1-micron and 2-micron lasers.
Okay.
And they interact with the plastic in different ways, which kind of impacts the characteristics of the weld.
Okay. So break it down for us. What's the difference between these lasers?
So a 1-micron laser is designed to pass through that transparent top layer of plastic
Okay.
and be absorbed by the layer underneath.
Okay.
And this creates a really concentrated, narrow, heat-affected zone.
So very precise.
Very precise.
Okay.
Now, a 2-micron laser works a little bit differently.
Okay.
It actually heats both layers of plastic partially,
Uh-huh.
and so it creates a larger heat-affected zone. So this makes it useful for welding clear-to-clear plastics,
Okay.
which you couldn't do with the 1-micron laser.
Gotcha. So each laser has its strengths and weaknesses.
Exactly.
All right.
Depends on the application.
So speaking of materials, do you have to be careful about what types of plastic you use?
Absolutely. Material compatibility is key.
Okay.
The plastics need to have the right properties to interact with the laser. One layer needs to be transparent to the laser wavelength,
Okay.
and the other layer needs to absorb it.
Right.
And if they're not compatible, you're not going to get a good weld or any weld at all.
And this whole process is happening at a molecular level.
That's right. It's all about the laser energy interacting with the plastic molecules
Okay.
to melt them and then resolidify them.
Wow, this is fascinating stuff.
Yeah.
But before we go too deep into the molecular world, I want to see how this is used in practice.
Okay.
What are some examples of how laser plastic welding is actually being used?
Well, the videos you shared actually showed us two different applications. One was a filter application
Okay.
where they were welding a filter media to a housing and then a cover on top of that.
Yeah.
And then the other one was using a two-cavity tool
Right.
to weld two sets of parts at the same time.
Gotcha.
And it even incorporated laser marking
Oh, wow.
and a system for automatically rejecting any bad parts.
So it's very versatile.
It really is.
Yeah.
We see it being used across a huge range of industries.
Okay.
From car parts and medical devices to consumer electronics.
Okay.
It's really everywhere.
Wow, it's literally everywhere.
Yeah.
This is amazing how this technology is changing the face of manufacturing.
Yeah, it really is.
It sounds like it's replacing some older methods as well.
It is things like adhesive bonding, ultrasonic welding, even mechanical fastening.
Really?
Yeah, there's a number of reasons for that.
Okay.
So, for example, ultrasonic welding uses high-frequency vibrations,
Okay.
which can damage sensitive components.
Right.
But laser welding is a non-contact process, so it eliminates that risk.
So it's gentler?
It is.
Gotcha. What about adhesives? I always thought that those were, like, pretty standard in manufacturing.
They are, but adhesives can weaken over time,
Yeah.
and they add extra material cost.
Okay.
And they might not hold up in extreme temperatures or harsh environments.
Right.
So laser welding can be more durable and reliable.
Okay, so it's winning out over adhesives on a lot of fronts.
Yeah.
And what about traditional, like, mechanical fastening?
Yeah, using screws or rivets
Right.
can kind of compromise the aesthetics of a product,
Uh-huh.
and they add unnecessary weight.
Okay.
Laser welding creates those really smooth, seamless designs.
Right, so it's all starting to click now.
Yeah.
So laser plastic welding is faster, cleaner, more precise.
Yeah.
Creates stronger, more reliable joints.
Mm-hmm.
It's no wonder that this is being hailed as the future of manufacturing.
It's really exciting technology, incredible potential.
But like any technology, I imagine there are limitations.
There are.
Okay, so what are some of the challenges that come with using laser plastic welding?
So one of the biggest hurdles is material compatibility.
Okay.
Like we discussed, you got to choose the right plastics,
Right.
make sure they absorb and transmit the laser energy properly.
Okay.
And then the cost of the equipment itself can be significant.
Mm-hmm.
You know, laser welding systems require a pretty big upfront investment.
Right.
And then they also require training to operate correctly.
Yeah, of course.
So you need skilled technicians who really understand the technology.
Yeah, those are definitely things to consider.
Yeah.
For sure. But for the right applications, it seems like the benefits outweigh the drawbacks.
Absolutely.
So now that we've covered like the fundamentals
Uh-huh.
and kind of explored some real-world applications,
Yeah.
I think it's time to dive into some of the more advanced concepts
All right.
of laser plastic welding.
Let's do it.
Things like quasi-simultaneous welding, contour welding, and the use of mirrors
Ooh.
to direct a laser beam.
I like where this is going.
Yeah, let's take this deep dive to the next level.
Okay. Welcome back to the Material Science and Advanced Manufacturing podcast.
Okay, so we were just talking about the incredible precision and speed of laser plastic welding.
Right.
So I want to see how it's actually used.
Yeah.
What kind of cool examples do we have?
Well, the videos that you shared with me actually gave us a couple of good applications.
Okay.
So one was a filter application where
Uh-huh.
they were welding a filter media to a housing,
Okay.
and then they were welding a cover onto that assembly.
Yeah, I remember that one.
Yeah.
And it was amazing how fast those lasers were moving.
Yeah.
And weren't they using like multiple lasers at the same time?
They were, and that was a way to kind of distribute the heat more evenly
Okay.
and prevent any burning,
Okay.
especially because they were working with nylon,
Right.
which can be sensitive to heat.
Gotcha.
So it's a really good example of how engineers are using laser welding in creative ways.
Absolutely. What about that other example with the two-cavity tool?
Oh, yeah, that one was all about efficiency. So they were welding two sets of parts at the same time,
Wow.
and they were incorporating laser marking,
Yeah.
where they were using the laser to etch information onto the parts.
Oh, wow.
And then they also had a system for automatically rejecting any parts that didn't meet their standards.
So they were really getting a lot out of that laser.
They were.
It's incredibly versatile.
It is. It's used across a huge range of industries.
Like what?
So in the automotive industry,
Okay.
laser plastic welding is used to create everything from fuel tanks
Okay.
and sensors to headlights.
Ah.
All those applications where strong leak-proof seals are super important.
Yeah, I can definitely see how the precision would be really critical
Yeah.
in those cases. So what other industries are using it?
The medical field is using it a lot
Okay.
for assembling catheters,
Okay.
filters, and other devices where hygiene and contamination control are really important.
All right, those are non-negotiable
Yeah.
for medical devices.
Oh,
for sure. We're,
Well, the electronics industry relies on it a lot
Okay.
for things like sealing sensitive components,
Uh-huh.
like battery housings,
Okay.
microelectronic enclosures.
so it's everywhere.
It's in consumer goods
Okay.
for appliances, wearable tech.
So laser plastic welding is literally everywhere.
It is.
This is really amazing how this technology is changing the face of manufacturing.
It's pretty cool.
Yeah, it sounds like it's even replacing a lot of the older Method?
And it's like adhesive bonding,
Oh.
ultrasonic welding,
Right.
even mechanical fastening.
Really?
Yeah.
Why is that?
Well, there's a number of reasons. So, for example, ultrasonic welding.
Okay.
You components.
Oh, so they can't use that.
Right, but laser welding is a non-contact process, so it eliminates that risk.
Oh, okay, so it's gentler.
It is.
What about adhesives?
Yeah,
I always thought those were pretty standard for manufacturing.
they are, but adhesives can weaken over time, and they add extra material costs,
Yeah.
and they might not hold up in really extreme temperatures
Yeah.
or harsh environments.
Yeah.
Laser welding is much more durable and reliable.
Okay, so it's kind of winning out on a lot of fronts over adhesives.
It is.
So what about traditional mechanical fastening?
Well, using screws or rivets
Right.
can really kind of compromise the look of a product,
Uh-huh.
and they add a lot of weight.
Okay.
Laser welding creates those really smooth, seamless designs that we talked about.
Right. Okay, so it's all starting to click now.
Good.
So laser plastic welding is faster,
Mhm.
cleaner, more precise, creates stronger, more reliable joints.
Yeah.
It's no wonder it's being hailed as the future of manufacturing.
It is a really exciting technology.
Yeah.
It is. It has incredible potential.
But like any technology, I imagine it has limitations.
It does.
So what are some of the challenges that come with using laser plastic welding?
Well, one of the biggest hurdles is material compatibility. Like we discussed, you have to choose the right plastics
Right.
that absorb and transmit the laser energy effectively.
Right.
And the cost of the equipment itself can be a big factor.
Uh-huh.
Laser welding systems require a pretty substantial upfront investment,
Right.
and they require specialized training to operate them.
Yeah, of course.
You need skilled technicians who really understand the technology.
So those are definitely things to consider
They are.
when deciding whether to adopt laser plastic welding.
Yeah.
But for the right applications, it seems like the benefits far outweigh the drawbacks.
Absolutely. Now that we've covered the fundamentals
Right.
and explored some real-world applications,
Yeah.
I think it's time to dive in some of the more advanced concepts of laser plastic welding.
Okay, like what?
So things like quasi-simultaneous welding,
Okay.
contour welding, and using mirrors to direct the laser beams.
Ooh. Okay, I'm ready.
Yeah.
Let's take this deep dive to the next level.
All right.
Welcome back to the Material Science and Advanced Manufacturing Podcast. We just finished talking about some of the real-world applications for laser plastic welding
Right.
and how it's being used in all sorts of industries.
Yeah, it's pretty amazing.
It is, and now we're going to take things up a notch
Okay.
and delve into some of the more advanced concepts behind this technology.
All right, I'm ready.
So what's first on the list?
Let's start with quasi-simultaneous welding.
Okay, I remember you mentioning that.
Yeah, so you know how in one of those videos we saw two lasers working at the same time?
Right.
That's actually a form of quasi-simultaneous welding,
Right.
where the laser beam rapidly moves around the joint,
Mm-hmm.
melting the plastic as it goes.
So instead of one continuous weld, it's more like a bunch of overlapping spots.
Exactly. And this gives engineers more control over the heat distribution,
Okay,
which is really important when you're working with larger or more complex parts.
that makes sense. So what about contour welding?
Contour welding is similar to quasi-simultaneous welding, but it's even more advanced. It involves actually following a very specific path or contour along the joint, which makes it really great for parts with intricate shapes or curves.
So it's like the laser is tracing a pattern
Yes,
and creating a weld that perfectly follows the shape of the part.
you got it.
That's so cool.
This really opens up a lot of possibilities for designers
Right.
because it allows them to create welds that are both strong and aesthetically pleasing.
So they look good and they function well.
Exactly.
It sounds like these techniques are really pushing the boundaries of what's possible.
They are.
With laser plastic welding, are there any other techniques that are really pushing the envelope?
Well, there's one more I wanted to mention, and that's using mirrors to direct the laser beam.
Okay.
Remember in those examples, it seemed like the laser was bending around corners?
Yeah, it was like magic.
Right, or reaching into tight spaces.
How do they do that?
It's all about the mirror placement.
Okay.
By strategically positioning mirrors within the welding setup.
Engineers can actually manipulate the path of the laser beam,
Wow.
allowing it to reach areas that would otherwise be inaccessible.
So they're like bouncing the laser beam around
Yeah, they are.
to get to where it needs to go.
Exactly.
What kind of applications is that good for?
Well, it's really helpful when you're welding round parts or
Okay.
components with complex geometries.
Okay.
So things like a fuel tank or a medical implant
Right.
where you need a really strong leak-proof seal.
Uh-huh.
But those parts often have really intricate shapes
Yeah.
that make traditional welding methods difficult.
This is really mind-blowing stuff.
It is pretty amazing.
Yeah, it seems like laser plastic welding is becoming more versatile and sophisticated all the time.
It really is.
What does the future hold for this technology?
Well, I think laser plastic welding is going to play a huge role in shaping the future of manufacturing.
Okay.
We're going to see even faster welding speeds,
Okay.
greater precision,
Uh-huh.
and the ability to weld a much wider range of materials. So lighter, stronger, more complex products.
Exactly.
What about the impact on design?
That's a good question.
How will laser welding influence the way products look and function in the future?
Well, designers are going to have a lot more freedom to create really intricate and seamless designs.
Uh-huh.
Imagine products with hidden weld lines,
Okay.
complex curves, and integrated functionality
Wow.
that were impossible before.
Yeah.
It's going to change the game.
This has been an incredibly insightful deep dive
It has.
into the world of laser plastic welding.
Yeah, it's been fun.
Thank you so much for sharing your expertise.
You're welcome.
For our listeners who want to learn more, where can they go?
I would recommend checking out the Material Science website.
Okay.
They have a ton of great information.
Perfect. We'll include a link to that in the show notes.
Good.
As we wrap up this episode, I want to leave our listeners with one final question.
Okay.
What industries or products do you think will be revolutionized by the precision and efficiency of laser plastic welding?
That's a good one.
Think about the possibilities,
Yeah,
the challenges,
right.
and the incredible potential of this technology.
A lot to think about.
That's all for this deep dive, folks. Thanks for joining us.